All right, guys. So I realized that with substitution, we need a little bit more because there are tougher problems with substitution. So check this out. I did the work ahead of time just because with technology, there's such a lag when I actually write it out, and it wasn't really working. So here we go. Let's say you have a linear system, and this linear system is not really in y equals. You're not gonna do it by graphing, and you've been tasked with solving it by substitution. So, and I'm really talking about mastery level stuff right here with IXL. So you got your first equation, 6x minus 4y equals -6. Your second one is 10x minus 7y equals -7. And where do you even start? Not a single one of them is in y equals. Not a single one of them is in x equals. You don't know what x is. You don't know what y is, or where they intersect. Now, we'll say, again, if you were to graph this, to use Desmos, which I think lets you graph in standard form, you could find the intersection, boom, you'd have it. It's -7, -9, and that's it. All right, here's how you do it by hand, which is very useful for you. I want you to learn how to do this. All right, so the first equation, what I'm going to do is I'm going to manually solve it for x. All right, so what I started doing is I moved my -4y, I moved it to the right side. All right, so I added it to both sides. So I have 6x equals -6 plus 4y. Then I divided everything by 6. So I have x equals -6 divided by 6 plus 4 divided by 6 times y. Now to simplify, -6 divided by 6 is -1. And 4/6 is really 2/3. So there I have it. I have now an equation that is solved for a single variable. It is an x equals. And I could have solved for y as well. But I want to take the first, whichever one of the two equations, and I want to solve it for a single variable. All right. With my second one, what I'm going to do now is I'm actually going to do substitution. So I'm going to take this expression that I came up with that represents x, right? And I am going to substitute it, wrong place, right here, for this x. All right. So my equation is 10x minus 7y equals -7. So when I substitute my expression that I solved in the first part, I have 10 times -1 plus 2/3 y, quantity, minus 7y equals -7. Then it's about distributing, and I picked a hairy one, right? This one is one with fractions. It might look a little difficult. It's not bad. Distributing the 10 gives me a -10. Distributing the 10 to the 2/3 y gives me 20/3 y. Then I have minus 7y equals -7. To clean this up, I added 10 to both sides, so I have 20/3 y minus. Went ahead and put -7y in thirds to get a common denominator. I call it 21/3. That's an easy fix. You can do multiply the 7 by 3/3. So I have 20/3 y minus 21/3 y equals 3 because I did add the 10 to both sides. Now I'm going to combine my like terms. 20/3 minus 21/3. It's going to give me -1/3. So I got -1/3 y equals 3. You can do this last step in a number of ways. You can divide both sides by -1/3, or you can also multiply both sides by -3. Either one will do the trick, and you get y equals -9. All right. And after that, what we've got is we need to solve for x. So now that we know y, all we have to do is substitute my y in to my equation. So I'm going to do it with the 6x minus 4y equals -6 equation. So here I go, 6x, and you could substitute it into either one. 6x minus 4 times -9 equals -6. So 6x plus 36 equals -6. I'm going to subtract 36 from both sides. So I get 6x equals, this is a -42, all right? And divide both sides by 6, and I get x equals -7, all right? So that's what I've got. And let's check to see if IXL approves of our work. I got x equals -7, y equals -9. Again, if you are a little paranoid about, you don't want to get the answer wrong, you don't want to go back in your SMART score, check this one by graphing. But you do need to know how to do this by substitution. When I submit this, it's going to say, well done, all right, like a steak. So this is fantastic. Hope you guys learned a little something from that. That is how you use substitution when you have a linear system that is in standard form. All of these skills are going to transfer to our work with other nonlinear systems. So fantastic. Good job, guys.